All right, today we're going to start on a new chapter. Chapter 4. There's not a ton of calculations at the beginning of this chapter. Okay? So we're going to go through this. The one thing we don't have in this classroom is a periodic table on the wall. I got to figure out a way to get one in here. I'll have to let put one up. Right. Chapter starts off with a picture of a farmer. What the heck does a farmer know about chemistry? You might know any farmer? He knows what's in his soil, doesn't he? He knows about nitrogen and phosphorus and potassium and pesticides and herbicides. He knows how to calculate dosages. He can do dimensional analysis in his head. Right? Because he has to know exactly how much fertilizer or how much pesticide to use, right? If he uses too much, he's wasted it. If he doesn't use enough, it doesn't do what he needs it to do, right? So he has to do these calculations continuously. If you go talk to him, he won't have any clue what you're talking about, dimensional analysis. But I guarantee you he can do it in his head. He can convert how many acres he has, how much crop he has, how much nitrogen in the fertilizer, and he'll tell you how many gallons he needs to add per acre, stuff like that. I mean, they can do all that in their head. Because they've been doing it for years, right? That's the way farmers are. So they know a lot about different elements, too, and how these plants grow. So, we'll start by talking about elements. Passing around and passing out some sheets. These are the elements. Humor. These are the elements, right? Right here. These are the elements, right? If you look at this, right now, there's 118 slots on here. Everything that we know about the universe is made up of these elements. Okay? Now, I pass these out all the time, and I tell students, take notes on these. Okay? That's why I'm giving them to you. If there's extras, just hang on to them. I'll give them to the end of the class. Take notes on them. Okay? When we take our midterm or our final, I'll give you one. Okay? This is not to be memorized. This is not second grade. We don't do memorization in here. We use this as a tool to solve problems. Okay? And that's what we're going to use this for. So we're going to talk about the elements. The elements are pure substances from which all other things are built. There are 118 of them. Well, not quite yet, but almost. They cannot be broken down into simpler substances using ordinary means. Okay? And they're on the inside of your cover, or they're on this sheet right here. Here are some common ones, right? Or some that you may have heard of before. We have uranium. Anybody ever heard of uranium? What is uranium for? Huh? It's radioactive, and so what do they do with it? Build bombs. It's also used what? In nuclear power plants. Okay? Where does that name come from? It comes from the name of the planet Uranus, right? So the names of the elements come from all kinds of places. Some of them come from mythology. Some of them come from old Latin or Greek names. Some of them are named after people. Some of them are named after places. Like curium, named after Madame Curie. We talked about her in here, right? We talk about Madame Curie in here? No. Who knows who Madame Curie is? Was? Anybody know who she was? She was a female chemist / physicist, right? She did do what?
Did you win the Nobel Peace Prize?
Not a Peace Prize.
Oh, what a Nobel something.
She won a Nobel Prize in Physics and a Nobel Prize in Chemistry. There's a whole bunch of Nobel Prizes every year, right? Only one of them's called a Peace Prize. The rest, most of them are for science. Okay? She won 2 of them. Very rare. There's only been 3 people to win 2 Nobel Prizes. She's one of them. She worked with her husband. They both died of one thing. Radiation poisoning. Because they worked on radiation. They were the people to figure out why radium is radioactive. Okay? So Some of them are named after places like Californium or Berkeleym, or Livermorium or Darmstadtium. Okay? Or Americium, named after what's Americium named after? Not that tough, huh? All right, so they're named after all kinds of stuff. And when you look at that periodic table that I handed you, what stands out first on that periodic table? The big letters, don't they? Those are the symbols because chemists are inherently lazy. So we abbreviate everything. Just like those prefixes we had before and all that stuff. We do the same thing with these symbols. Note every one of the symbols is either a single letter or it is a combination of letters with the first one being capital and the second one being lowercase. So I'm going to give you some elements and I want you to tell me what they stand for. Whoa. What the heck? Try again. Really? Oh, that's a nice effect. Seriously? Ha!
CU is copper.
Well, I'm not trying to put CU. I'm trying to put a C. Carbon. California. Very good.
Calcium.
Very good. That's calcium, Ca. What the heck is going on with this thing? It was acting up this morning, too.
Chloride. Chloride.
Ooh, look at that. Made it work. What element's that?
Calcium.
It is not. That was calcium. That's calcium. What is this? That's the postal code for mail and letter in California. It's not two elements, is it?
No.
All right. Carbon again, right?
Yeah.
What about that one? Chromium. What about that one? I don't know what it is. It's nothing to me. Look, some of you people with your fancy little handwriting are going to do like an R like that. That's a capital R. Look, my name starts with R. I know that's a capital R. That's a little r. That's a capital R. That's wrong. Okay? Fair enough? All right. Some of the names don't really match the symbols very well, do they?
No.
look at a few of them.
Gold.
Yeah, let's do a few. We can start with K.
Potassium.
The way I remember that one is Special K cereal versus that.
Phosphorus.
Phosphorus. Potassium, phosphorus, both start with P. Can't have two elements that are both P, right?
Why would they start one with a K?
Well, probably because the Latin or Greek name for potassium start with a K. That's why it's a K. Same thing with gold and silver. These come from the Greek names, right? Aurum and argentum or something, right? So they come from the Greek names. Right? Mercury, right? That's a G.
Iron.
That's an F. Why is that iron? That's an F. Comes from the old Greek word ferrum, which means iron. You may have, if you go to a scrap yard, you'll see signs up, ferrous metals over here, non-ferrous metals over there. What does that mean? It means things that have iron in them go over here. Okay? Gotta know that. Never been to scrap. Who's ever been to a scrap yard before? I'm not lying, am I? My favorite one is this one.
Tungsten.
Tungsten. That does not look like this. Man, that was writing great. What's going on with this thing? Anybody? Why is it W instead of that? This one actually comes from the German word for tungsten. Okay, tungsten was discovered in Germany, and they call it Wolfram.
What is it?
What is tungsten? Anybody know where you find tungsten at in your house? It's used in welding some. It's used in some jewelry. You can buy tungsten carbide jewelry now. It's really strong. Where do you find tungsten? Everybody has some in your house, probably. Who said it? Who said light bulbs? Where at a light bulb? In the filament. If you look at a light bulb in your house, right? The old incandescent bulbs, right? It looks like it's got like a little like that, right?
The thing that shakes.
This little coil right here is made out of tungsten, right? And it's the thing that glows when you put current through it that makes light. You know what Thomas Edison, you know how many tries it took Thomas Edison to discover that tungsten worked as a filament? Like over 1,000 tries. You know what somebody said? You know what he told somebody? They said, wow, you really had a lot of failed experiments. He goes, no, every one of them worked. There's had like 1,000 ways not to make a light bulb. Well, it takes one way to make a light bulb, right? They weren't failed. He learned something by each one of them. Even though he failed, he learned, right? Just like when you fail on the homework, you should learn something by that failure. Oops, that didn't work. Don't let me do it that way again. You do it the same way twice, you think the answer's going to come out different? What did Einstein say? That's a definition of insanity. Doing things the same way over and over, expecting a different outcome? Not going to happen. Okay? So, those are some of the elements that have different symbols than the name would indicate, right? And that's what these are right here. So, think about these real quick and we'll do them together real quick. I'll give you like 30 seconds to do all 5 of these. What a bag you got there. You can move around in that thing. Good gracious. All right, ready?
Yes.
What's the symbol for iodine?
I.
Where is it on a periodic table? It's over towards the right-hand side, right?
Mhm.
Okay. What about for iron? It's not I, we already gave it. It is
Mg.
magnesium.
Mg.
What's Mn?
Miss.
That's manganese. Seems often confuse these. That's magnesium. This is manganese. Where do you find magnesium at?
Left side.
Huh?
Left side.
On the left side of periodic table. Where do you find it at home? Milk of magnesia. You don't know what milk of magnesia? It's like Pepto-Bismol.
Oh.
That's magnesium hydroxide. What's zinc? What's the symbol for zinc?
Cn.
Zn. And the symbol for nitrogen?
N.
It's the easy one, right? Oop. All right. Give me the names for each of these. Another 30 seconds. So I'm not going to ask you to memorize this periodic table, but you're going to learn a lot of them just because we're going to use them over and over. We'll use certain ones a lot. Your handwriting's dang near as bad as mine.
You only gave us some 30 seconds.
Yeah, well, I lie sometimes. All right, ready? P stands for
Phosphorus.
Al is
Aluminum.
Mn,
Manganese.
manganese, right? H,
Hydrogen.
hydrogen.
Potassium.
K is potassium. We already talked about